Okay, I hope you can answer the quiz before this. Now I'm going to show you the implementation of fuzzy rules. Okay, in this case, we are going to decide how fast we can drive, okay, based on these rules. Okay, so you have this rule, if it's sunny and warm, drive fast. Okay, so this is the variables that we use. Okay, if you remember the predicate logic, okay, so cover sunny, okay, and temperature is warm, then we drive fast, okay, the speed is fast. If it's cloudy and cool, okay, that means the cloud cover, alright, and also the temperature is cool, so the speed will be slow. Okay, so driving speed based on these rules is the combination of output from these rules. Okay, so how can we proceed? Okay, so given the values of these rules, for example, we have the temperature here 65 degree Fahrenheit or equivalent to 18 degrees Celsius. So I hope you can understand how cold it is, 18 degrees Celsius, and also 25% cloud cover. So that means it's not too cloudy, right? Or mendung. It's 25 degree only, 25% only. So how fast should we go, or how slow should we go? So using a fuzzy logic, first in the fuzzification process, okay, we need to project or map this information into the membership value. So if you can see here, okay, we have four fuzzy values here. We have freezing, okay, which is from 0 degree Fahrenheit, okay, until 50 degree Fahrenheit. Okay, but it's 100% freezing, okay, it's from 0 until 37, that is 0 degree Celsius. Okay, so that means the water is frozen at 0 degree Celsius. So using a Fahrenheit, it's lower. From 0 degree Fahrenheit until 30 is frozen, and then it's becoming cooler, okay, from 30 to 50 degree Fahrenheit. Okay, from 30 degree Fahrenheit until 70 degree Fahrenheit, they call it as a cool. Okay, still cold but not freezing. Okay, cool, and the most ideal cool temperature is at 50 degree Fahrenheit. Starting from 50 degree Fahrenheit until 90 degree Fahrenheit is warm. Right? Warm, where the peak is at 70 degree Fahrenheit. And again, starting from 70 until 90, it's starting to become hot. Alright, and it is really hot from 90 degree Fahrenheit until the rest. Okay, so the membership is dependent on us. So maybe this is used in European countries or United States where they have this freezing or snowy winter. Right? Okay, so if we have the temperature at the time is 95 degree Fahrenheit, so we project here, 65. So this is 60, so this is 65, right? So draw a line, alright, and then you have to read the value here. What is the projected value? Okay, to know how cool it is or how warm it is. So we can see that this line, okay, intersect with cool, the blue line, alright, as well as with warm, the lime green line. Okay, so it's intersect with the cool at 0.3, okay, and it intersect with warm at 0.7. So the degree of membership function, okay, we can say it's belong to cool, okay, 30% belong to cool membership and 70% belong to warm temperature. Alright, next we work out with the other attributes, okay, that is the cloud cover, 25% cloud cover. So again, we project a line here at 25% cloud cover, okay, and it intersect with the green line at 0.1 cloudy. The green line belong to cloudy, right, partly cloudy. Alright, so 0.1, and it also intersect with the yellow line that is sunny at 0.7 here. Alright, so we can say that at 25% cover, that means it's only 10% cloudy or partly cloudy, and 70% sunny. Okay, so based on this, okay, we put it back into the rules. Okay, so there are two rules here. If it's sunny and warm, right, dry fast. So the sunny cover that we can get, okay, from previous is 0.7 and 0.7. Okay, recall here that is a sunny and warm, the temperature. Okay, so this one sunny, okay, and also from the temperature warm, 0.7. Alright, so we get this. Okay, so 0.7 and 0.7, we take the minimum, which is 0.7. So the value for fast, okay, how fast we go is 0.7 or 70% fast. Alright, how about the second rules? Okay, we have to use the second rules as well. If it's cloudy and cold, drive slow. Okay, so again, we take the value that we read from the graph previously. Okay, so we have here cloudy as 0.1, okay, or 10% when it's 25% cover, as well as its cool temperature 0.3. Okay, therefore we map it back into the rule. Okay, we map it back to rule 0.1 and 0.3, take the minimum, that is 0.1. Okay, so 10% slow. So how to project this into the output? Okay, after we evaluate these rules, okay, we give the value for the rules. Okay, we start with the defuzzification process, okay, constructing the output. So this is the graph for the speed. Okay, so we categorize driving as slow from 0 mile per hour until 75 mile per hour. Alright, and fast, starting to speed up, starting from 25 mile per hour, okay, until 100. And so how do we do this? From the values that we get in rule evaluation, okay, we need to find a centroid where the membership is 100%. 100% belong to slow membership or fast membership. Alright, so first, this is where it's 100%, right? Because here it's on half-half. Okay, it's half fast and half slow. Similar with this area, okay, it's becoming faster and less slow, okay, in this area. Alright, so find central of these two areas. So we have readings at 25 mile per hour and also 75 mile per hour. Okay, so what is the speed? Okay, we have to find the weighted means that is at 25 degrees Celsius. It is it's 10% slow. Okay, 10% slow. Okay, so this is 0.1, okay, times 25. Okay, that is the speed at that time. Okay, plus the value here. Okay, okay, that is at 75 with the 70% fast. Okay, so 70% faster that we get from the rule evaluation just now, times with the 75 mile per hour. Okay, add these two together, divide by the 0.9. Where do we get 0.9? Is the addition or the total of 0.7 and 0. This should be 0.1 again. Alright, and this is 0.8. Alright, so okay. Right, so the new value of the calculation would be 68.75 mile per hour. That is the driving speed that the car would proceed or decide, okay, based on the input that we give, or maybe the sensor read from the temperature. Alright, so the other usage of fuzzy logic is in temperature controller in air condition, as well as in a freezer. And I will give you also a link in YouTube, and you can find more actually on how they implement the fuzzy logic control in rice cooking. Alright, so I hope you understand the topic and enjoy the world full of fuzzy. Thank you.